start. Basically what we do is whoever the reader is has read the stuff and they will summarize the pertinent content there. I think the most exciting part of this stuff really is the discussion, the whys, the who's, the practical experience. So I think in reading I go, oh, maybe we're a little ambitious, or for all I know, we all know all the answers already and we'll go through the first 50. So it all depends on the stuff. But I think the questions like, hey, why did I do that? Oh, well, my first-hand experience is always the best. I'm going to turn it over to Diego.
All right. So we're going to start with chapter 1.
Yeah.
And all right. So it starts with a small introduction to how to view the world that surrounds us. It says, the world that surrounds us is procedural, and it's actually both procedural and object-oriented. Meaning, there's a time flow that goes in a continuum. I cannot watch myself on a 30 seconds delay. So it keeps going in a continuum. People interact with each other, and there's a lot of actions happening. And then you also have objects, right? And you don't have to, like, for example, make an example of somebody stepping on a cat's, like a person walking and stepping on a cat's tail. Mm-hmm. And like, you don't have to like come up with all the possible combination of, a bike running on a tail, all that kind of stuff, but you just need to have like an object, a person, being able to walk and stepping on stuff. And then another object, cat, that doesn't like to be stepped on. And you toss the two together and you kind of have the reaction they would expect it. Beyond that, it talks about design. What is design? And what does it mean? And what problem does it solve? So pretty much, and the point is, we do design so that not just we have software that works, because you can do software that works without any design whatsoever. It can be a mess of code and still works and be a successful piece of software. There are plenty of that around. But also, there is a pleasure to work on. And normally, that means it's a pleasure to work on when you have to touch it or change it. Because software will eventually change. And so like this design solves the problem of changing requirements. A well-designed piece of software, it's easy to change. But to get to that point is it's a journey. And the reason why it's a journey is when you start writing the piece of software, you don't have all the information that you need to write the software. You don't have all the information for a whole bunch of different reasons. Because you are not familiar with, you don't have the domain knowledge necessary to understand everything that's going on with that particular object. Plus, people come up with new, now they like the software so much, they want to improve it and do some other stuff that they were not thought about before. You might also have technical problems that are completely extraneous from the domain knowledge. Now this is like a very, whether if it's a website, whatever, it's a wonderful website or app or whatever, now you need to scale it. That brings other issues. So changes is inevitable even when the software is perfect. And also you need to do, so the design helps you with the changes, but you need to just do just enough design based on the knowledge you have at the moment that you're writing the software. And that is tricky. it's tricky for many reasons, because it's you can write something, and there's another book, 99 Battles of O. It's a great example. It writes like the same, something that writes 99 bottles of beer, and it gives you like I don't know how many variation how you can write that, and each branch is like, if you take this approach or that approach or that approach, it goes like, oh yeah, this is like a beautiful like it's solid and everything, but it's like impossible to read. So like it's always like it's an art and balance of your expertise, the software, and what you value in the software. All right, that was like a little aside. So then we talked slightly why change is hard, and
let me interject real quick. It's not bad for those who are not talking to follow along in the book to get a feel, because you might have a question, as Diego's talking about, like he's hitting like why change is hard, which seems like page. I don't know, I can't tell what pages in Kindle.
I'm trying to follow the
right, and so other people might ask a question like, oh hey, blah 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 blah, and if you're using Kindle you can highlight stuff, but go ahead. So all right.
So pretty much a lot of it has to do with coding is really a lot of organizing code, where which object, when we talk about all coding, object-oriented programming, we talk about like, okay, which object are you going to create and instantiate, and how you're going to instantiate them, what kind of capabilities they're going to have, what kind of method code, method naming, all that kind of stuff. And all it is like logistics, right? You got to be careful to delineate the boundaries of each object. And also manage dependency. That's a big thing, because if it's imagine like the example of the cat, right? Mm-hmm. So this is not in the book, but a cat has a heart, right? So you might have a cat object, and inside the cat object you might have a heart object, right? Makes part of the cat. The cat cannot live without a heart. And if you organize the code so that there's a cat and inside there's a heart class, there's a cat class and a heart class inside of that, it means that the cat, like their heart cannot be used for anything else, right? Because you're not going to put a cat heart on a horse. But realistically, most hearts are about the same, and for the purpose of coding, yeah, you can say a cat with a heart of generic type, right? And it will work, it will pump blood. All you care is that pumps blood. So, and that is like one of the things about managing dependency. You will never organize the code in a way that you instantiate a heart with a cat, passing a cat into a heart, and now you have, it would be like a weird thing to think about, but it's pretty straightforward. But when you talk about real life problems, that is not very straightforward, but you kind of need to think about it in those terms when you manage dependency. Also, why managing dependency? Because when there's too many, when an object knows too much about what its dependencies are, it becomes tightly coupled. Meaning everything needs to be just so perfect. It's kind of like What's the fairy tale about the three Goldilocks? It's kind of the Goldilocks. Oh, this object is, it's like a three argument is 1, 2, and in this specific way, you need to do it just so that you get the correct object, right? And when that happens, is what it is like you create a whole bunch of dependency on either on the type of object that are inside, like the cat knows too much about the heart. For the art, you might have to pass like a number of valves. How many valves, the size, how much blood per hour it pumps, all the kind of stuff. And if the cat object has to know all about that kind of stuff, you need to like kind of feed them some way, and that creates a tightly coupled sets of classes. And say, well, if we come up with a new DNA and we come up with something like a cyborg cats, now you have to extrapolate all that kind of stuff and come up with, like, rewrite the whole cat class for cyborg cat. Where if you were just injected a heart, now it's a plutonium, a vibranium. What's the
unobtainium?
Unobtainium heart testing. So pretty much, and generally, poor design, a piece of software that's poorly designed starts when they're small, right? There's a piece of software is small, it works, it's poorly designed. As it gets bigger and bigger, it turns it into a bigger, poorly designed thing. And actually, I don't know if it's in this chapter or in the next one. I'm going to just mention it because it's like whenever you write code, a piece of code, even if it's like something that is quick, you should always try to adhere to some principle. It needs to be transparent, meaning like you need to look at the code, understand what it does. It needs to be reusable, and it needs to be exemplary. Meaning, you need to write code that other people can look and use as a reference to write more code, right? So, like they're going to look at it and say, "Oh, this is a good example," or even not even a good example. If people see that, they're gonna just use it because, I guess over here in this project we do things this way. Right. So like if you start with bad design, the bad design gets replicated, it grows. And a part of the design again is to align with change. So you want to write code for the feature that you're writing today, but also write code that's easy to be changed for the futures to come. And again, we're not asking programmers to be clairvoyant and see the future. We're asking pretty much to not anticipate what the application is going to do, but because we cannot do it, we need to accept that we cannot do it. But just allow to postpone some design decision to a later time when we're gonna know more. Right? And there are certain design principles that you can follow that allows you to do that. But you're not gonna start writing, I think, I'm gonna need this in this class, or I'm gonna need that, and come up with features and methods just in case somebody's gonna use them. Because every time you write something new or a method, that becomes a piece of legacy code they're gonna have to maintain, right? So you want to do just the minimum interface for the current job and just enough design that you can then change it later without affecting anybody else. They're using the interface that you decided upon today. So, and now we are on the tools of design. And pretty much just like in any other thing, we have certain criteria or principles that we can follow, which are solid, single responsibility, open close, list code substitution, interface segregation, and dependency inversion. Other principle that she mentioned is dry, don't repeat yourself, which I found is like one of the hardest one. It's easy. It's very easy to do poorly. Mm-hmm. And low demeter, which I cannot remember his name. And that famous Ruby guy I used to blog all the time. He used to say feature envy, pretty much. Mm-hmm. When you see yourself, like you see a class that is changing a lot of methods, again, you have a cat that is like, I don't know, you might have a cat that has a heart, and you might say heart that pump, but you might also say heart, the pump, the valve left, the something else. Now you start going, all of a sudden you kind of like getting into the business of what the heart is doing. Like it's kind of feature envy. Like let's say that you want to do it like it causes a stroke or a heart attack to this cat, and you want to do the heart attack method, and you do heart pump, left ventricle, that stuff. Well, that's probably not. That method would not have to live inside of the cat. That was a pretty dark example. I'm sorry, I'm killing cats.
Diego and his bionic cats example is really,
I know, right?
Really odd.
I should probably just use like the example in the book, but they don't have an example right now. I don't want to anticipate example that are coming up.
Yeah.
So because of all this solid stuff, all this design principle, solid, dry, LOD, low demeter, people are coming up with also metrics, how to, validate this good design. And metrics, one of the first metrics was like lines of code, which of course was not a good one. Because it was saying, well, if somebody doesn't know how to code very well, we write a lot of extra code, right? So if you just go by lines of code, the guy that produces more lines of code is a better programmer. Then all the junior programmers have to be fantastic. Write a lot of extra code, they're like rocking it. On the other side, like the people have done like experiment studies of the real application, and they say, yeah, well, some other stuff, and like a cyclomatic complexity and stuff like that, actually are good metrics to use. Now, the thing about she also mentioned design patterns, which helps dealing with common problems. Now, the problem with all the metrics in general is that if the metrics are bad, generally you're almost guaranteed that the design is poor. But if the metrics are good, it doesn't mean the design is good. It's not that. But no, it's kind of like everything. You can game. Right? Oh, I'm going to extract this, extract that, extract methods. Everything is very simple. But maybe all your boundaries are like all out of whack. You might have, again, the cat that knows that doesn't even have a hard object. It just pumps blood in and out, does everything on its own. Everything's coded specific for that cat. It knows everything about it. So it's still bad design.
Those metrics are negative metrics. If you fail, it's certainly bad. But just because you pass doesn't mean it's good. It's kind of like a programming test. If you fail this easy test, you're probably not a good programmer. But just because you pass this test doesn't make you a great programmer.
Right. Or It's kind of like if anybody has read the Black Swan. Yeah, you did, right?
I've seen Black Swan.
Oh,
Probably
no,
not the
yeah,
same
yeah,
thing.
okay.
Yeah.
So in Black Swan, the main thing is knowing what you know, don't know what you don't know,
Mhm.
and so it's kind of impossible to prove a negative, but only a positive. So because you haven't been able to prove something, it doesn't mean that the something is not true or false. And the big thing was the Black Swan, because nobody ever seen a Black Swan. They thought a Black Swan doesn't exist, and it's impossibility. Then they found them. And the only reason was, so you can only prove that something is not true by example, but you cannot be absolutely sure that something is true. You can only prove it.
I think for Andrew, the cases are, first thing is you can have good code that does the wrong thing. You can have code that like small method size, that's supposedly good, but if you have to go through like 20 methods to figure out what happened, that's a nightmare maintenance wise, because your brain stack is like 4 to 6 things. A lot of times I'm in code, it looks short, the classes are short, the methods are short. Half hour later, I finally figure out what this method is because I had to go through 12 classes.
Yeah, and I wrote of that.
Things like that, and then another thing is, maybe the thing that you made easy to change is not the thing that really needs to change. So you have this great code. I can plug in one of these, but that's not even the problem. The problem is this other thing over here. So those metrics of, you got low cyclomatics or small method size or stuff, it doesn't necessarily mean it's good for the job at task.
So going back, the chapter is the act of design, and pretty much is like talks about how it's up to the programmer and there is level of experience to do good design, right? Because now you got the Gang of Four design patterns in the book. Most programming patterns are there available. You got solid, you got dry, you got this. All the problems solved, right? You should be able to write beautiful code all the time, perfectly designed. Unfortunately, part of it has to do beginner programmers. They implement, design patterns a little too eagerly, or some of the stuff they see a pattern when there isn't one. That happens a lot. Or they over-design something when something much simpler would have worked. Bob Martin once gave a whole talk about, I think it was a Ruby conf, where he brought this piece of software that was doing his job, and it's been running for like 10 years or so. And then went back at it and went, oh, this is a piece of garbage. So started rewriting it and everything. And then afterward, like it was like spend the whole day rewriting this thing, and then I realized, no, it was fine the way it was before, because it does this thing. It really has never changed. It's never gonna change, because the specs are just what they are for this thing. So like it wasted a whole day just to realize there was good enough design. And it was Bob Martin just like, I don't know, 6-7 years ago. So when we screw up, we should feel pretty good. Like, let's not over design stuff. She talks about like, undesign application usually carry their own seed of destruction because it comes with it, right? They're easy to write and run and everything, but as code gets bigger, the progress comes to screeching a halt, and generally is because nobody has spent enough time designing them. I talked about it talks about how you can recognize the the beginner programmers, because they started agreeing any change requests. No, I can add the feature. It wasn't designed to do that. Or when somebody else does a design or comes up with features that are not really needed, and other programmers are forced to write those applications. Say, well, I can certainly write this, but it's not what you really want, and you will eventually be sorry. Which, I think I've said a few times. So when to design? Next chapter. And next to design talks about the big design up front. And part of the point that Sandy makes here, she thinks the big design up front existed mainly to assign blame. Meaning, with a big design up front, because there's so much documentation, so much talking about it way ahead of time, if then you deliver the software and the software does everything that the document said, but now you want features that are not in the document, guess what? The blame is in the people that did not give you the proper requirements. And then if if it actually doesn't do what's in the document, then it's a programmer's fault. So it's a blaming. The big upfront design is a blaming game. And in the agile, she talked about how the agile process is better, but it's a very hard sell. Meaning, the typical phrase is, we don't know what we're doing, and we don't know when it'll be done. Right? That's what you're saying, or how we're gonna do it. We don't. It's like that's a pretty hard sell to tell somebody. Right? So but the iterative process allows you, if you apply correctly or the principle, to handle change as change arrives. Because at least I don't know how many people have done big design up front, but even here that we are like on a pretty short schedule, we might have changes within a week from from when we decide something, right? So if we were to do like a 3 months of design and then just develop what we decided after 2 months of that, it would be a nightmare after that. So let's see. I have like stuff like highlighted, so I know the thing that I like about this. So pretty much, okay. So the last thing that you mentioned, this is like the agile process guarantee change. Pretty much it says change is inevitable, so let's just plan for it. And if you cannot write well-designed code, you'll have to rewrite your application every iteration. So if you have to do that, you'll eventually learn. That's my take on that. There's a chapter about judging design. It goes into source of language of code, how bad metrics are essential to the design, but not the opposite is not true. And there's a couple cautionary tales about bad metrics.
I think her key aspect in that section was time interval that matters.
Yeah, so like one of the things she talked about is like the ultimate software metrics, I'm reading it, would be cost per feature over time interval that matters, which is nice and calculated because you got cost, feature, and time. It's hard to track. Yeah, in real life, this is like an impossible metrics to have. maybe some super organized team where you can start writing, clock the thing, and time everything for feature, and it's time with your salary and all that kind of stuff. Maybe it's all tying together. Maybe that would be possible.
The closest thing that's realistic to that is tracking time to, in our case, we use the pivotal card, but tickets. Right. If you log your time and metrics, and the bigger government agencies will do that. They'll log lines of code, maybe even time to each thing, and they'll try to pull metrics, which may be okay. But what I found interesting with the time interval that matters is ultimately it's probably going to go to everything depends. It's like if your time interval matters, like if we don't get this product by next week, our company fails.
Right.
And next week, if the time interval matters, and whatever the technical debt is, it's okay because if we get past Friday, we have a job. As an extreme, it's nice to do per week.
That's actually something that I lived through a couple companies. So it's totally true. I mean, sometimes you have to say, we don't have time for design, and we have to. I know that we got this is technical debt that we are accumulating, but it matters to get it now rather than later. So. Again, you can still try to make it, like even when you write it, and in the next few chapters, like she talks about how to isolate problem areas. Meaning you can write code in a way that this is bad, or it's in a way that kind of points out, let's say, it's not bad. Points out those things that needs to be fixed. So as you go, it becomes a jump at you when you reread the code. Oh, maybe this shouldn't live here, right? And then there's a brief introduction to object-oriented programming. It talks about procedural language, where you have pretty much data and sets of operation that are given to you, and then object-oriented language, where now you have object with data, with behavior, and they can all interact with each other. Let's see, and then you can kind of come up with your own method. So in a way is, and by the way, the way I see object-oriented is a little bit procedural in a way, but inside the methods, right? Mm-hmm. There's always at some level some procedural thing happening, and it's generally very rare that there's never anything procedural, like in any method or even like when you launch the application, it's usually start the server, do this, connect to the database. That just the sequence. Whenever you have a sequence of events, is a procedural. That's just my take on it.
You can think of it like encapsulated, though,
yeah. You so let me see. And so pretty much, I guess the summary is you're trying to encapsulate and prepare, good design, aimed at getting ready for changes in the future. And then pretty much every chapter has a different singular responsibility. Actually, if you think about it, so she has a chapter just on single responsibility, both for methods and for classes. A chapter just on managing dependency, using the same example. A chapter for flexible interfaces, typing, behavior, inheritance, and all that kind of stuff. So she kind of, I kind of enjoyed it while I was reading it. I was like, oh, she kind of applies the solid to the chapter itself.
Mhm.
So
Yeah.
you can read just one of them, and they, well, she might make a reference to a different chapter, a different, what chapter was this? A different section of the book. You can read one block, one chapter, and they're like, yeah, she covered everything about this thing.
That's what you mean by solid. That she's
You mean SRP.
So I personally, I'm enjoying this, even though I did read it like really late at night.
All right, let's take a break here. Anyone have any questions or discussions besides Andrew, who's on the same mic as Diego? Everyone's muted, so if anyone made any comments, we didn't blow you off. Anyone got any comments? Question, Tom, Sam, Brett. Anything you didn't understand, Andrew?
I'm here.
Like in the summary thing, they talk about the trick to getting the biggest bang for your design buck. That's, I think, the big thing that we're talking about. You can do too much design. You can do too little design. You can design for the wrong things. The key is getting the bang for the buck, having a design that makes your life happy, which, how do you do that? That really depends on your situation. And that time interval sometimes matter. Hey, this is due by Friday. Well, then you got to get out the door. You know. And sometimes you can say, yes, but I've got to do this thing for the long term. Yes, but if the competition beats you because you're going to have it by Friday, then you don't have a job. It doesn't matter. So,
and generally, I mean, I try to write, like whenever I code, I try to write in a way so that I kind of do it as a habit, so that I'm trying to see, and I'm using like a more of the techniques from Canback, almost called them Canback. Canback implementation patterns. So like if I use like his like type of like everything kind of looks the same kind of complexity, or the same type of what you call it? There's a name for it. I cannot think about it now. So like let's say you have a method and everything is kind of like one single word, like code this, code that, code this, and then there's one that says this times 2 divided by 4 times some other method. That thing
should be its own method.
Should be its own method, because it's not uniform, right? So if you have something that is you have a method that just calls a bunch of methods, and one of them is one of the lines like a bunch of different things, make that method so they all look kind of the same. And the reason, like some of the stuff, for me at least, helps me figuring out where I have some weirdness in the book, right? Unfortunately, I don't do it now, but like as we're gonna go like through some of the other chapters, you'll see like she started with a bad example, which is like totally plausible. It's like good enough for the beginner, or not even beginner development. It's the beginning, like, starting point of code, right? But then, you know, and I write that so many times, that type of code, and then I'm like, you know what? I'm gonna change this thing, change that, and then I have something that looks a little better. I'll definitely study that. Then I need to see, does this work? Does this fix the problem at a time? And once I have it working, I can refactor it.
There's a lot of, and she talks about that in this case, there's a lot of art and experience. And so when I think about what do I look for, I really want code that I can revisit easily and both understand and change. And sometimes, I don't know if you understand, these are at conflict with each other sometimes. Like what seems like a good structure when you're writing it isn't as good when you come back 6 months later and you look at it. Like it made so much sense, and now I'm trying to fix this, like changing 3 classes, or I had to read, the methods 12 times before I figure out what was done, even though they seem to read good. It's tough. It's like this thing that I'm doing on the side. I got asked to revisit something I wrote like a few months ago, and I go, oh, well, I did it right because it was that easy to change. I wrote like a quick test, and I changed it in seconds. I did a good job and I dried it, and I did some other things, but it was like, oh, I don't remember this code, but thank God I did it right because it's really easy to change and understand.
So, like in the chapter that about managing dependency, talks about some type of coupling that most people don't think about, which is not about object, but it's about methods, instantiation, parameters, like very low level type of coupling. And so most of the time, I kind of do the approach that she talks about, but sometimes I don't on purpose because I don't foresee any changes in that code. And doing the other way is like, this is like, it's going to require a little more typing. And I know it might be a little lazy, and there might be some good reasons still to do it in the way that we'll see eventually. But it's like, yeah, if it's like, especially if it's a one-off kind of thing, that's all you need. There's no change in a script that you're going to run just today.
Don't prematurely optimize.
Yeah.
Don't prematurely optimize. It's really easy. Oh, I can make this better. Hey, you're going to run it and throw it away? Don't do it. I mean, if you want to practice it, but it's like, I think programmers always want to polish it better. But,
so many times, I have my TextMate. I don't know, anybody else uses TextMate? No? So one of my favorite features is the TextMate is whenever it's my scratch paper, right? You open TextMate and pops up. You say, okay, I want a new window, and I'll write whatever I want. And sometimes it's stuff, keep the school, laundry list, errands, all that kind of stuff, right? If you close, even if you have not saved any of those, right? When you reopen, they all come back. The same location with the same content and everything. It's like my favorite feature of TextMate. Because I don't want to write all these files, and because if I save them and close, they actually sometimes they don't open back up. Like I don't save them, they do come back up. So it's kind of like it's my little sketch paper I can just bring up. Oh, I forget something. So all the time I write scripts. They are one-off, and then I keep them there. And then if I don't reuse them, like after 3 months or so, I close the window. So like if there was like good enough script, good enough design. We don't need to save this and have it anywhere else. Don, Andrew, no, sorry, Alex.
That's her.
Dude,
Brad. By the way, I don't know who's Sam. Who's Sam?
Sam's Don's friend.
Oh,
Yeah, that's my friend from Chattanooga.
Oh, cool. Sam, would you understand me?
Yeah, I did. It was actually a great overview of the chapter. I read it last night, and looking forward to reading the rest because I definitely relate to some of the issues here. I mean, I feel like generally I don't have an issue solving problems in my head, but a lot of times I'm kind of paralyzed with fear that I'm going to be backing myself into a corner in the future. So yeah, really looking forward to it.
All right. Don?
Yeah, it looks good. I especially like the line about if you're truly doing Agile, then you can't have a delivery like a delivery date that you're targeting,
Right.
which is interesting.
Yes, the bosses hate that. Right?
Yes.
But it's Bob Martin has the best sell on Agile. The way he explained to Benjamin is you get more of what you want sooner. That's the way to explain Agile because of the iterative. You're going to get, because what happens is, you know, in waterfall, you get something. It's just often not what you want. Right. So you get more of what you want sooner.
Yeah. So is there anything else?
We got 7 minutes. You want to start the next, or if there's no other discussion,
Let's see.
or we could wrap it and you can start clean next time.
I think I'm just gonna mention the true. Let me see.
True is actually in the next chapter.
It is next chapter.
Yeah, it's in the SRP chapter.
I'm trying to figure out.
So that's a
Yeah, actually, you know, we'll talk about next time. But yeah, she has like a nice acronym. True, transparent, reasonable, usable, and exemplary. So I mentioned transparent. You know, it should be obvious. Both, you know, what the code does and change it, what the changes might be, right? Which that is not always the case, or almost always. Reasonable. So the cost of any changes should be proportional to the benefits of the change that the change achieves. Usable. So existing code should be usable in new and unexpected way. And some of the stuff we were talking about, like it was a cat? A cat, yeah, cat with a heart. So changes to the heart, changes to the cat should not affect the heart or the cat like that much. And exemplary. So the code itself should encourage those who change it to perpetuate this quality. And I really like that. You know. And if you kind of like when you touch the code, again, it talks about what is the thing about the broken window? What's
oh
this?
yeah, no broken windows, because once one window is broken, then all the other ones get broken. Once you accept the first one, the rest of them get broken.
You familiar with that? But there's a name for it. Is that it?
That's it. It's in the pragmatic programming. He makes an example. If you got this car and it's like it's been abandoned, it's like it's fine. But the first window is broken, next thing you know, the next day it's completely looted. All the windows are broken, the tires are stolen. Once it's okay to see it broken, people just accept it.
Like now I'm going to incriminate myself. As a child, there was this big hangar almost close to my house, and then one day walking back from school, and there was like a few broken window, and like when I heard this thing, I was like, oh yeah, that's like totally rang a bell with me, because like, oh yeah, my brother and I and this other kid, we started putting in rocks at the rest of the windows to see how many we will break.
It's I don't know if you said this, it's a criminology theory. It was introduced in 1982 by social scientists.
Yeah. It's I think the first time it was written from programmers is in the pragmatic programming. Yeah. They call it this is the pragmatic programmers. This great book of like 52 tips, some of which are like the core of Agile. A lot of it is software craftsmanship. Dry comes from that. Like, you know, broken windows, they call it. That basically broken windows is keep your code clean. Because once you're okay with this crappy code, then all the other code gets crappy because, hey, it was okay there. It's also my theory why JavaScript looks so terrible. Because if you look at your jQuery examples, it's write your data in the DOM, put everything, intermingle it. Well, that's the example. And everyone says, oh, that's fine to write my JavaScript like that. So all JavaScript looks like that because when you Google, the first examples are these little not good code.
That's way better than what it used to be, right?
Yeah, but I'm just saying.
Worth shit on anything shit on PHP. Sorry for the language. But no, but like for example, PHP, it was until PHP 5 that they hired the designer, the language designer. And then they introduced classes and all that kind of stuff. It still needed to be better competitive. Or they've done the work, but just think about how good enough design can get you. It's PHP 4. So no design at all, but like super powerful business is built upon it, and
Yeah.
great piece of software. I in it, definitely. There was
Amazing.
So I guess we just need to find the programming equivalent of the stop and frisk. Maybe we can call it stop and fix.
stop and fix, yeah.
That's Diego. Diego refactors code all the time. He's Mr. Stop and Fix. Let's call him the code police.
And I think on your guys' PRs, I tell you. All right, cool.
All right, we can wrap it.
And
1 minute to go.
yeah, let's call it early.
All right.
We gotta decide who's going next.
Enjoy that 1 minute. Go crazy.
Ah, I'm gonna take a walk.
There you go. Oh, you're done.
Thanks.
All right. In 2 weeks.
Thank you guys for having me. I appreciate it.
Enjoy.
Welcome.